Lesson 51, Simplifying Rational Expressions with Like Denominators. On example 1, it says find the excluded value in each expression. So all we're doing on these is looking for the excluded value. I hope that you remember from previous lessons that excluded values are where the denominator is equal to 0. So looking at A, my denominator there is this 8p. So what I'm going to do is I'm going to set 8p equal to 0. Okay, so to get p by itself, I see that 8 and p are being multiplied. The opposite is to divide. What I do to one side, I must always do to the other. So I'm left with p equals 8, which means my excluded value is 0. So for this to be simplified, p cannot be equal to 0. Or for this to be defined, p cannot be equal to 0. So this is my final answer. P is not equal to 0. On B, I would like for you to pause the video at this point and try to do that one on your own paper. So, once again, we are only looking at the denominator when finding excluded values. So we're going to take this c minus 6 and we're going to set it equal to 0. So I have c minus 6 equals 0. To get c by itself, I need to add 6 to both sides. So I'm left with c equals 6. And this is my excluded value. So like I said before, we are going to say that c cannot equal 6 because if c is equal to 6, then this is undefined and we don't want it to be undefined. So this is my final answer. C is not equal to 6. It says simplify each rational expression. If possible, identify any excluded values. So on A, we are going to start, I always like to start by finding that excluded value, okay? So I'm looking at that denominator, and I'm going to say that 24y is equal to 0. To get y by itself, I divide by 24 on both sides. So I get that y is equal to 0, or that y cannot equal 0 for this to be simplified. And then I have 6y to the third over 24y. So I am trying to figure out what I can do to simplify. Well, you should know that if I just had 6 over 24, I would reduce that, right? I would reduce it by 6. So 6 divides into 6 one time, and 6 goes into 24 4 times. You should also know from previous lessons that I don't ever want to have the same base in the numerator and the denominator. So this is raised to the third power, this y is, and this y is raised to the understood first power. I always want to move the smaller exponent, so I'm going to move this y to the first. When I move it up, I'm going to change its sign. So since it was positive, I'm going to subtract it. So what I have on top is 1, which I don't need to show, y to the second over, this is now 4. And this is true where y is not equal to 0. This whole thing is my answer. Okay? Alright. For B, we're going to start the same way. We're going to look at that denominator and find any excluded values. So I'm going to say that 5g minus 10 cannot be equal to 0. I'm just going to start skipping this step because I'm kind of lazy and I like to skip steps. So I'm going to say that it's 5g minus 10 cannot equal 0 because that's where my excluded value is going to be. So to get g by itself, I'm going to start by adding 10 to both sides. So I have 5g equals 10, does not equal 10, excuse me, does not equal 10. And to get g by itself, I'm going to divide by 5 on both sides. So I get that g cannot equal 2. That's my excluded value. What I'm going to do next is the simplifying. So I'm going to start with the original expression, which is g minus 2 over 5g minus 10. And on the top, there's not anything that I can do, but on the bottom, I hope that you can recognize that we can factor. So on top, I'm going to leave it as g minus 2 over, I'm going to factor 5 out of both. So if I take a 5 out, open my parentheses, if I take 5g divided by 5, I'm left with just g, minus 10 divided by 5 is 2. Now this is a quantity of g minus 2, and this is a quantity of g minus 2. I can cancel those two things. Now I can only do this if it's that whole quantity, if it's in the parentheses and if it's being multiplied. I can't do it if it's being added to something else or something like that. It has to be that whole quantity, okay? So what I'm going to do now is write my simplified answer. I'm going to bring it down. So on top, when that cancels, I hope that you remember that it cancels to a 1 over 5, and this is true where g is not equal to 2. That's my final answer. I would like for you to pause the video and try to do C on your own paper, please. Okay, on C, we're going to start by looking at that denominator to find our excluded values. So I'm going to say that d plus 3 cannot be equal to 0. And to get d by itself, I'm going to subtract 3 from both sides. So I'm left with d cannot equal negative 3. That's my excluded value, where d is negative 3. And then I'm going to rewrite my original equation, which is 7d squared plus 21d over d plus 3. On top, I can factor. So I can see that I can factor out a 7 out of both terms, and I can also factor out a d out of both terms. So I have 7d, and I open up my parenthesis, and if I divide 7d squared by 7d, I'm left with just d plus 21d divided by 7d. Those d's will cancel, but 21 divided by 7 is 3 over that d plus 3. So this is, again, those are quantities, so I can cancel those quantities, and I'm left with just 7d, which is true as long as d is not equal to negative 3. Simplify the rational expression if possible. These are fractions, okay? And as long as they're fractions, we know that to be able to add or subtract fractions, we must have a common denominator. So I'm subtracting here. I have a common denominator, so I can write this as one fraction. So I'm going to put 2m minus m over that n squared, my common denominator. So all I have to do now is combine my like terms that I have on top, which is 2m minus m gives me just m over n squared. That's my final answer. As long as I have a common denominator, I can write it as one fraction, combine like terms, and I'm done. On B, right now it doesn't look like I have a common denominator, but we have some problems with the way that this is written, or at least I hope that you see that we have some problems, because I don't ever want to have these negative exponents. So I'm going to put this first fraction over 1, and I have s to the negative 3. To make that a positive, remember we move it across the fraction bar so we can change its sign. I have t over s, which is now to the positive third, plus this t to the negative first. To make it a positive, I move it up. So I have 12t over s to the third. And now I have a common denominator. So I'm going to write it as one fraction. So I have t plus 12t over s to the third. And on top I have a common denominator. So when I put those two things together, I have t plus 12t, which is 13t, over s to the third. Final answer. Alright, it says 2 pieces of ribbon are missing from around a pillow. One piece is z over 3z plus 9 meters long, and the other is z plus 6 over 3z plus 9 meters long. How much ribbon is needed to complete the pillow? Well, if this piece is missing and this piece is missing, I need those pieces to complete the pillow. So I'm going to add them together. So I have z over 3z plus 9 plus z plus, that's a z, plus 6 over 3z plus 9. I have a common denominator, we can see that. So I'm going to write it as all one fraction, z plus z plus 6 over 3z plus 9. And I have z plus z, because those are like terms, which is going to give me 2z plus 6 over 3z plus 9. And I can simplify this a little bit by factoring. So on top I can factor out a 2, and I'm left with z plus 3 over, on the bottom I have a 3 that I can factor out, and I have z plus 3, which means I can cancel the quantity of z plus 3, which leaves me with 2/3, and my measure is in meters. So I need 2/3 of a meter to finish the pillow. And that's my final answer, and that's all I have for you today. I hope that you've taken good notes and that you have a good night.